Today we're going to take a deeper look at orbit. So we're going to start with orbitalmechanics.info. So this is the link that's in your Schoology assignment. And we're going to start by just adding an orbit right here. This is a basic orbit, and I'm going to scroll wheel out. So I'd like you to do this with me. So remember, you can always take a window and you can slam it over to the side, and then you can put my video or the whatever this is on the other side, so you can kind of see both at the same time. So please do that so you can kind of follow along here and practice this with me. So as we click, we can rotate around this orbit, and what I want you to do is I want you to pay particular attention to these items here. A is semi-major axis. So as we change this, we're changing the size of the orbit right here. E is eccentricity. So if I make this 0, we have a circular orbit. And I is your inclination. So I'm going to set this inclination right now to 90 degrees. And that's going to be the easiest to kind of review these. 89 is close enough. So let me turn this. So what I would like you to do right now is set it something similar. I don't really care so much about what your semi-major axis is. But I want your eccentricity to be 0 and your inclination to be about 90. So make yours like mine. And now that we have this orbit, we can kind of look around here. The thing I want you to take a look at here is the little baby omega. So this one is argument of perigee. Now, argument of perigee pivots around the foci. So if we have a circular orbit, it doesn't look like it's doing anything at all. But if we change our eccentricity, so let me drag this down, and then I adjust my argument of perigee, you can see it's pivoting around the foci. So that's how you can change a highly elliptical orbit that's going way down here in the south, and you can make it go up here in the north. So remember that as we get further away, we slow down. So we would see way more of the North Pole right here because we're going really slow, and then we start to speed up, and then we zip around, and then we kind of repeat. So depending on what you want to see a lot of, if you'd want to see a lot of the South Pole, you might make a orbit that looks something like this. And so we have to adjust the argument of perigee to make that happen. So let's look at our last one here. This is the RAN. RAN pivots it around the z-axis of the Earth. So it doesn't matter which way the orbit is. So z-axis of the Earth. So as I adjust my argument of perigee, if I do this, you can see we're still pivoting around the z-axis of the Earth, and it's pivoting about the foci. So that's why it's pivoting there. We always have one foci in the middle of the Earth. So I want you to make sure that you are aware of this, because you're going to have to create some orbits, and you're going to have to adjust some things like potentially argument of perigee or eccentricity or whatever it might happen to be. Notice again, if we have an eccentricity of 0, argument of perigee doesn't look like it's doing anything. Although if there was a satellite here, adjusting it would make a different orbit because the satellite would be starting there instead. And then there again is RAN. So that is the orbitalmechanics.info.